Hi, my name is Vinay Kumar from College of SVC. Today our topic is computer graphics and visualization. In that 2D pipeline, 3D pipeline, RGB and CMY color model we are discussing today. So firstly 2D pipeline. In computer graphics and visualization, the 2D pipeline refers to a sequence of stages and processes involved in the transformation two-dimensional objects and scenes into a final reminder image, a display or output device. It en- encapsulates various operations such as modeling, transformation, rasterization, and rendering. Here is an example of the key stages of 2D pipeline. First is modeling. The first step in the 2D pipeline is modeling, where the objects are senses to be rendered are defined and created. This involves specifying geometric primitions such as points, lines, curves, and polygons that repeats the shape and structure of the objects. Second one, transformation. In the transformation stage, the object's coordinates and attributes and manipulates to position, scale, rotation, and otherwise modify them in the desired way. Transformation includes transformation, rotation, scaling, shearing, and more. And next one is clipping. Clipping. After the transformation, After the transformation, the object may extend beyond the boundaries of the viewing area or viewpoint. Clipping is a process of determining which part of the object are visible within the viewpoint and discarding the invisible portion. This prevents rendering unnecessary geometry and optimize performance. Rasterization. In the process of converting vector-based object into a raster image processed of pixel, each primitive in broken wood down into fragment or pixel that covers a portion of the primitive's area. The fragments are then processed to determine their attributes such as color, depth, and texture coordinates. Fragment operations. In this stage, various operations are performed on each fragment to determine its final color and other attributes. These operations including lighting, calculation, texture, mapping, transparency, blending, and other effects that contributes to the visual appearance of rendered image. Next is display. Display. Finally, the process fragments are mapped on the display devices or output medium. The fragment and combine the form of complete image, taking into account factors such as their depth values and transparency. The resulting image is then displayed on the screen or saved as a file. Here is a simple diagram illustrated and for the 2D pipeline, that is object world coordinating and clipping, that is applying window and object subset, window to view mapping, simple 2D drawing pipeline, that is display, rasterization, and object screening, that is comes after the window viewpoint mapping. Next, moving on with the 3D pipeline. In 3D pipeline, there are modeling. Firstly, this stage involves creating or importing 3D model using modeling software or tool. Models are composed for vertices, edges, and faces, which defines their shape and structure. Transformation. In this stage, the 3D model are transformed to a desired location, orientation, and scale in a virtual 3D space. Common transformation includes transformation, rotation, and scaling. These transformations are typically represented using matrices. Clipping and culling. Clipping is a process of removing objects or part of objects that fall outside the view features, which defines visible portrayal of the scene. Culling is a removal of objects or portion of objects that are not visible due to occlusion and other factors. Projection. This stage maps the 3D scene onto a 2D plane known as the project plane or viewport. Common projection technique includes perspective projection and orthographic projection. Rasterization. Rasterization Rasterization is a process of converting the transformation 2D objects into pixel and the screen. Each triangle or polygon is broken down into fragments or pixels that cover its surface. Vertex processing. Vertex processing involves performing calculations and transformation on individual vertex. This stage can include vertex lighting, vertex blending, and other vector vertex specific operations. Fragment fragment processing. Fragment processing operates on individual fragments or pixels. It includes operations such as texture mapping, shading, and depth testing. And next on the 8th point is pixel operation. This stage involves additional operations on individual pixel such as blending, filtering, and post processing effect display. Finally, the processed pixels are sent to the display device to show on the screen. Here is a simple diagram of the 3D pipeline, that is 3D viewing pipeline, and prevent modeling, viewing, hiding, lighting, OD, projection, and lastly is projection. And next, moving on with the RGB and CMY color model. Here RGB red, green, blue color model and the CMY can magenta yellow color model are two commonly used color models in computer graphics, imaging, and printing. RGB color model. The RGB color model is a additive color model, meaning that color are created by the adding different amount of red, green, and blue lights. In this model, the primary color are red, green, and blue, and they can be combined in different intensities to create a wide range of colors in the RGB color. Each color channel is typically represented by an 8-bit value ranging from 0 to 255, where 0 represents no intensity and 255 represent maximum intensity. When all the RGB color channels are combined at their maximum intensity, the result is white, and when all the channels are at their minimum intensity, the result is black. By varying the intensities of the three primary colors, different color can be achieved. For example, maxing red and green light are their maximum intensity create yellow, while mixing red and blue light creating magenta, and so on. The RGB color model is widely used in the electronic display such as computer monitor, televisions, and digital cameras, as they emit light differently. And CMY color model. The CMY color model is a subtractive color model used in the printing and mixing pigments. In this model, the primary colors are can, magenta, and yellow. When combined at full stretch, they theoretically absorb all lights and produce black. In in practice, additional color are used to create a more accurate black, as the mixing of ink is not perfect. The CMY model works by subtracting different amounts of light from white, which is absence of color. When the three primary colors are combined at full strength, they produce a natural gray. By varying the amount of each primary color, different colors can be achieved. For example, mixing can and yellow pigment creates green, while mixing magenta and yellow creates red, and so on. In practical applications such as printing, and CMY model is often combined with key, that is K channel, to create a CMYK color model. The K channel represents key color, which is usually black. Adding the black improves shadow detail, reduces the amount of ink required, and provides better control over the final print color. Overall, the RGB color model is primarily used in emitting lights, while the CMY colors model is used to subtractive mixing of pigments, especially in printing process. So that's all. Thank you.